Namaskaram. Today's topic is length of plane curves rectification. What is rectification? Rectification is nothing but finding the process of the length. So we are finding length of the curve. So rectification is the process of determining the length of arc of a plane curve whose equation may be given in Cartesian, parametric Cartesian or polar form. So how to find the length of the curve? So using integration we will find the length of the curve. See, what is a plane curve? Plane curve is it is nothing but a smooth curve which has a continuous derivatives. See, this is not smooth. So this curve is not a smooth curve because at this point it has no derivative. So we will find rectification, that means we will find for the lengths only for smooth curves using the integration. Suppose S be the length of the arc of the plane curve, C included between the lines x is equals to a and x is equals to b. Let y is equals to f of x be the equation of the curve C in Cartesian form. So now we will find the length of the arc in between the lines x is equals to a and x is equals to b. So divide the curve into n segments by n plus 1 points. Denote the point on the curve at each point by p of x comma y. See, so look at this. Here this is the plane curve. We are dividing the curve into n segments. So this is pi. So we will find the length. So by approximation, see this length of the curve will find by approximating by a straight line. So this is pi minus 1 comma pi minus 1 pi. This is the length of this line segment. So this line segment, what is the length of this? This is nothing but by using Pythagoras theorem. So change, suppose if you take pi minus 1 as xi minus 1 comma yi minus 1 and pi as xi comma yi. So change in the x coordinates, that is xi minus 1 will denote by delta xi and yi minus 1 by delta yi. So this length is, so by using Pythagoras theorem, this length is nothing but delta x square plus delta y square. Now this is the approximate length. We are finding the length of the curve by approximation of the straight line. So to get accurate value, so we will divide this n in larger and larger values. Then only we can get the, by increasing number of points on the curve, we will get the accurate length. So this pi minus 1 value is under root of delta xi square plus delta yi square. Now what is the total length? So this is only one segment length. So total length is nothing but sum of all these values I is equals to 1 to n under root of delta xi square plus delta yi square. By taking n value as a large value, so that is as limit n tends to infinity, sigma I is equals to 1 to n delta xi square plus delta y square. This gives the accurate value of the length of the arc. Now by applying the Lagrange's theorem for the ith interval. So what is the Lagrange's theorem? If f is continuous on the interval, on the closed interval, and it is derivable on the open interval xi minus 1 comma yi, xi, then there exists a point xi star such that f dash xi star is equals to delta yi by delta xi. Now delta yi can be written as f dash of xi star into delta xi. So now on simplification we are getting this value as 1 plus f dash of xi star whole square into delta xi. So if you remove from the, if you take out from the root, we will get delta xi square is nothing but delta xi. Now this is can be written as, this sum is nothing but from Riemann sum. So this can be written as integral a to b under root of 1 plus f dash of x whole square into dx. So that is equals to integral a to b under root of 1 plus dy by dx whole square dx. So that means if you want to find out length of the curve y is equals to f of x in between the lines x is equals to a and x is equals to b, then that length is nothing but integral a to b under root of 1 plus dy by dx whole square into dx. Suppose if the equation is given x is equals to f of y, then how to find the length of the arc? Then the y varies from, suppose if y varies from c and d, then the length of the arc s is equals to integral c to d under root of 1 plus dx by dy whole square into dy, if the curve is given in the form of x is equals to f of y. Then suppose if the curve is in terms of parametric equations. So already told you that we can find the length of the curve if the given equation is in the form of Cartesian, parametric Cartesian and polar form. Suppose given curve is in the form of parametric form. So how to find the length of the curve? Suppose equation x is equals to x of t and y is equals to y of t with the parameter t varying from t1 to t2, then the length is nothing but s is equals to integral t1 to t2 under root of dx by dt whole square plus dy by dt whole square into dt. So to find if the given equation is in the parametric form, we will find the length as s is equals to integral t1 to t2 under root of dx by dt whole square plus dy by dt whole square dt. Now suppose if the equation is given in the form of polar form, so r is equals to f of t. If the given equation of the curve is r is equals to f of t, f of theta, and theta varies from theta 1 and theta 2, then how to find the length of the curve? S is equals to integral theta 1 to theta 2 under root of r square plus dr by d theta whole square into d theta, if the equation is given in the form of r is equals to f of theta. Suppose if the equation is given in the form of theta is equals to g of r, then how to find the length? So if theta is equals to g of r, then the length of the arc s is equals to integral r1 to r2 under root of 1 plus r square d theta by dr whole square into dr. So in this way we can find the length for the given equation of the curves, whether it is in the Cartesian form or parametric Cartesian form or polar form. Now next we will go for one example. Suppose equation of the curve is x square is equals to 4ay. X square is equals to 4ay. So this is nothing but the parabola. This is a parabola. So x square is equals to 4ay. We have to find the length of the curve from one vertex to one end of the latus rectum. So how it will be? The parabola is whose axis is y axis, and this is the vertex O 0, 0. The latus rectum, what is latus rectum? Which is a parallel to the, which is a perpendicular to the axis of the parabola. Suppose this point is A, this is 2a, x is equals to 2a is the latus rectum. If x is equals to 2a, then what will be the y value? A. 2a comma a. Now we have to find the length of the arc OA. So the given equation is in the form of y is equals to x square by 4a. So it is in the Cartesian form. So what is dy by dx? Dy by dx is equals to 2x by 4a. X square differentiation is 2x, 2x by 4a. So 2 gets cancelled, x by 2a. Now what is the length? According to the formula, length is equals to, see here we are x varies from 0 to 2a. 0 to 2a. Under root of 1 plus dy by dx whole square into dx. So s is equals to integral 0 to 2a under root of 1 plus What is dy by dx? dy by dx is nothing but x by 2a whole square dx. Now, so s is equals to integral 0 to 2a under root of one plus 4a square plus x square by 4a square to dx. So, here we will write this as y is equals to a. Now, so by removing root, so we will get this as 1 by 2a integral 0 to 2a under root of 2a whole square plus x square dx. Now, so integration of this is, it is in the form of under root of a square plus x square. Under root of a square plus x square, integration is x by 2 under root of 4a square plus x square plus a square by 2. In place of a, we are having 2a, so a square is 4a square by 2 into sin h inverse x by a. A is here 2a. Now, what are the limits? Limits are from 0 to 2a. So, this is equals to 1 by 2a. Apply the upper limit, 2a by 2 under root of 4a square plus x square, that is nothing but 4a square plus 4a square by 2 is 2a square sin h inverse 2a by 2a. So, what is the lower limit when x is 0? So, apply the lower limit 0, x is 0, the lower limit is 0, sin h inverse. For this function, when x is 0, sin h inverse is 0, so we need not write the lower limit value because its value is 0. Now, 1 by 2a, so a 4a square plus 4a square root 8a square, that can be written as 2 root 2a plus 2a square sin h inverse 1. So, if I take 2a common, 2a square common, I am taking 2a square common. So, 2a square by 2a is a. So, the value will be a into this is equals to a into. So, I took 2a into a, 2a square common. So, root 2 plus sin h inverse 1. So, this is the required length. See, what is the given problem? We need to find x for the parabola x square is equals to 4ay from one vertex to one extremity of the latus rectum. So, what is latus rectum? So, this is a 0 comma a focus. Latus rectum is a line which passes through the focus and perpendicular to the axis. So, y is equals to a is a latus rectum for this, x square is equals to 4ay. When y is a, what is the x square value? X square is equals to 4a square, x values are plus or minus 2a. But in the given problem, asked only from one vertex to one end of the extremity, so this is the required length OA. So, here x is varying from 0 to 2a. So, what is the y value? Y is equals to x square by 4a. Now, differentiating with respect to x, dy by dx is equals to what we are getting? X by 2a. Now, the required length of the curve s is equals to integral 0 to 2a under root of 1 plus dy by dx whole square dx. This is the formula for the arc length. Now, substitute in place of dy by dx x by 2a. Now, substituting dy by dx as x by 2a, on simplification what we are getting? 4a square plus x square by 4a square. Now, under root 4a square, if you take out from the root, we will get the value as 2a. So, I am writing outside the integral 1 by 2a integral 0 to 2a under root of 2a square plus x square dx. Now, the integration of root 2a square plus x square dx, this is in the form of under root of a square plus x square formula. So under root of a square plus x square integration is x by 2 into under root of a square plus x square plus a square by 2 sin h inverse x by a. Now replacing a by 2a, we will get the value as like this. Now substitute the limits. Applying the upper limit, we are getting the value as in place of x we are substituting 2a, and in the similarly here also in place of x 2a. Apply the lower limit. If x is 0, the lower integral this value is 0 as x is 0, and sin h inverse 0 is also 0. So the lower limit will be 0. So what we are getting the value as 1 by 2a, a into 2 root a, because root 8a square can be written as 2 root a plus 2a square sin h inverse 2a by 2a is nothing but 1. So this can be written as, on simplification what we are getting, the a is equals to under root of sin h inverse 1. So using the formula, integral formula, so we are getting the length of the arc OA as a into root 2a plus sin h inverse 1. So this is the value. Next problem. Suppose the given equation is 6ay square is equals to x into x minus 2a whole square. What is the length of the loop of the curve? So we need to find, so this is also in Cartesian form, we need to find length of the loop of the curve. So this loop will be, so how it look like? So the given equation is, what is the given equation? Y square is equals to 6ay square is equals to x into x minus 2a whole square. Y powers are even, so therefore the given curve is symmetrical about the x axis. So how it will be? See, when x is negative, if x is negative, as the right hand side x into x minus 2a whole square is there. If x is negative, then y square will be negative, y will be imaginary, the curve does not exist on the real line. So therefore the curve exists only for the positive values of x. So when x is 0, y is 0, and also when x is equals to 2a, also y is 0. So that means this curve intersects the x axis in 2 points. So this is 0, 0, and this point is 2a comma 0. So we require OA, this total OA, the total length of the loop of the curve. So to find this curve, because it is symmetric about the x axis, instead of finding the total length, if you find only the above the x axis, if you take 2 times of that, we will get the required length. So for that, what I will take, the length of the arc is equals to, the length of the arc S is equals to, that means OAO, the total length, the required length is equals to 2 times integral. So here also it is varying from 0 to 2a. 2 times 0 to 2a under root of 1 plus dy by dx whole square into dx. So to find the total length, what is the formula? OAO, because it is symmetric about the x axis, I am taking 2 times integral 0 to 2a. This integral 0 to 2a gives the length of OA. So AO is also same as OA. So therefore I am taking 2 times integral 0 to 2a under root of 1 plus dy by dx whole square dx. So now we need to find, to substitute this dy by dx value, we need to find what is dy by dx from the given curve. What is the given curve? 6ay square is equals to x into x minus 2a whole square. So now y square is equals to x into x minus 2a whole square by 6a. Now what is y value? Y is equals to root x into x minus 2a by root 6a. Now we need to differentiate this. So root x into x can be written as x to the power of 3 by 2. 2a into root x is 2a root x. Now differentiating this. What is the differentiation of x to the power of 3 by 2? X to the power of 3 by 2 differentiation is dy by dx is equals to x to the power of 3 by 2 differentiation is 3 by 2 into x to the power of 1 by 2 minus 2a root x. 2a root x differentiation is 1 by 2 root x. This whole by root 6a. This is nothing but root 6a. Now, so 2 root x I am taking common, I am taking 2 root x as LCM. So 3 into root x to the power of 1 by 2 is nothing but root x. Root x into root x is x minus 2a by 2 into under root of 6ax, this is dy by dx. Now, 1 plus d, to substitute in the formula we require 1 plus dy by dx whole square. So, what is 1 plus dy by dx whole square? 1 plus 3x minus 2a whole square by 2 into root 6ax, 2 square is 4, root 6ax is 6ax. Now, this is equals to 4 into 6, 24, 24ax plus 3x minus 2a whole square, 9x square minus 2, 3 into 2, so that is minus 12ax plus 4a square by 24ax. See, 9x square, 24ax minus 12ax is nothing but 12ax. So, what we are getting now? 9x square plus 12ax plus 4a square by 24ax. 9x square plus 12ax plus 4a square can be written as 3x plus 2a whole square by 24ax. Now, we will substitute in the formula. S is equals to, so in this formula, so what is the S value? S is equals to the 2 times limits are from 0 to 2a under root of 1 plus dy by dx whole square dx. What is 1 plus dy by dx whole square? This is 3x plus 2a whole square by 24ax. If you take root, so what will get? 3x plus 2a by under root of 24ax into dx. Now, we need to integrate this. So, this is equals to this root 24a is a constant, will take out from the integral. So, 2 by root 24a. Root 24a can be written as root 2 root 6a, 4 into 6, so 2 root 6a, 3x by root x, integral 0 to 2a, 3x by root x, that is nothing but 3 root x plus 2a by root x. Now, integrate this. So, this is equals to 2 gets cancelled, 1 by root 6a, 3 root x, 3 root x integration is x to the power of 3 by 2 by 3 by 2 plus 2a by root x, 2a x to the power of minus 1 by 2 plus 1 by 2, that is nothing but 1 by 2 root x. Now, so 2 gets cancelled, this 3 gets cancelled. Apply the limits 0 to 2a. X to the power of minus 1 by 2 plus, sorry. So, this is equals to x to the power of 1 by 2 by 1 by 2. So, 2a. So, this is equals to, apply the limits 1 by root 6a, 2 into 2a to the power of 3 by 2 plus 4a into root of 2a. Now, this is equals to 1 by root 6a, 2 into 2a into root 2a plus 4a root 2a. So, what we are getting? The value as 4a plus 4a, 8a 8a into root 2a by root 6a. A gets cancelled, 3. So 8a by root 3. So the required length is 8a by root 3. So what is the given equation? Given equation is 6ay square is equals to x into x minus 2a whole square. So we need to find the whole length of the loop. So because loop is symmetric about the x axis, so instead of finding the total length, what we are doing, only the OA we are finding. So as x is varying from 0 to 2a, so what is the length of the curve? S is equals to integral 0 to 2a under root of 1 plus dy by dx whole square into dx. Now, so y equation, from the given equation, y is root x into x minus 2a by root 6a. Find dy by dx, substitute in 1 plus dy by dx whole square, simplify it. So we are getting 1 plus dy by dx whole square as 3x plus 2a whole square into 3x plus 2a whole square by 24ax. Root of this is nothing but 3x plus 2a by root 24ax dx. Now we need to integrate this with respect to x in the limits 0 to 2a. On integration, we are getting the value as x to the power of 3 by 2 by 3 by 2 plus 2a into x to the power of 1 by 2 by 1 by 2. Apply the limits 0 to 2a. Upper limit is 2a whole to the power of 3 by 2. Here 2a to the power of 1 by 2. If you apply the lower limit, if x is 0, the lower limit is also 0, here also 0. So that's why we are taking only the upper limit value. So on simplification, we are getting the length as 8a by root 3. Suppose if the given curve is in the form of Cartesian, we are finding the length of the loop. Suppose if the given equation is in terms of parametric form. So if it is in parametric form, what will be the length? S is equals to under root of dx by dt whole square plus dy by dt whole square into dt. So we need to take the limits for t. So for example, see here, so required length we are getting as 8a by root 3. Now for example, calculate the distance travelled by the particle p of x comma y after 4 minutes if the position at any time t is given by x is equals to t square by 2 comma y is equals to 1 by 3 2t plus 1 whole to the power of 3 by 2. So what we need to find? Distance travelled by the particle p. So the distance travelled by particle p is nothing but the length of the arc in between. See, when we have to find out after 4 minutes, that means for the curve, what is the time position? So time position is nothing but x is equals to t square by 2 comma y is equals to 1 by 3 2t plus 1 whole to the power of 3 by 2. Initially, what will be the time? Time t is 0. After 4 minutes, we need to find. So that means t is varying from 0 to 4. Distance travelled by p is equals to length of the curve. So that is equals to integral 0 to 4 under root of dx by dt whole square plus dy by dt whole square into dt. So what is the given x? X is equals to t square by 2. So now it is in the parametric form. X is equals to t square by 2. What is dx by dt? So differentiate x with respect to t. T square by 2 differentiation is 2t. 2t by 2 is nothing but t. Similarly, find out dy by dt. So what is dy by dt? Now differentiating 1 by 3 into 2t plus 1 whole to the power of 3 by 2. What is the function power? 3 by 2. So if you differentiate with respect to t, so 1 by 3 into 3 by 2 into 2t plus 1 whole to the power of 3 by 2 minus 1. Again, instead of t, what we are having? 2t. So 2t differentiation is 2. Now substituting these two values, this dx by dt and as well as dy by dt values in the formula. So what we'll get? Substitute dx by dt is t square and 1 by 3 into, so whole to the power of 3 by 2, so that is 3 by 2 into 2t differentiation is 2 into 3 by 2 minus 1 is nothing but 2t plus 1 whole to the power of 3 by 2. So that can be written as root of 2t plus 1 whole square. So according to the formula, under root of 1 dx by dt whole square plus dy by dt whole square dt. Now on simplification, the 2 gets cancelled and also 3 gets cancelled. So So this is under root of t square plus 2t plus 1 dt. This t square plus 2t plus 1 can be written as t plus 1 whole square. So if you remove root t plus 1 on integration, what we are getting? T square by 2, t integration is t square by 2 plus t. So what are the limits? Limits are from 0 to 4. Now substitute the limits. T square, that is 4 square by 2, 8, and t is 4 at lower limit. If t is 0, the lower t square is also 0, and t also 0, the lower limit will be 0. So we are getting only the upper limit value, that is as 8 plus 4, so 12. So that means arc length is nothing but 12. That means distance travelled by particle p is nothing but the 12 units. Suppose find the length of the asteroid x to the power of 2 by 3 plus y to the power of 2 by 3 is equals to a to the power of 2 by 3. So this equation, this will convert into the parametric form. So what are the parametric equations for this curve? X is equals to a cos cube theta, comma y is equals to a sin cube theta. Same, what will be the formula? Formula will be, because it is in the form of parametric, the x is in terms of theta, so we will write the formula as integral. So we will write dx by d theta under root of dx by d theta whole square plus dy by d theta whole square into d theta. And we need to find what are the limits for theta. So okay, because the function is x is given in terms of theta, we have to find out dx by d theta, that is nothing but 3a cos square theta into minus sin theta, because cos theta differentiation is minus sin theta. Similarly, dy by d theta is equals to 3a sin square theta, sin theta differentiation is cos theta. Now substitute these values in dx by d theta whole square plus dy by d theta whole square. So what we are getting, that value as 9a square cos square theta sin square theta. On simplification, because 9a square cos to the power of 4 theta sin square theta plus 9a square sin to the power of 4 theta cos square theta. In this equation, if you take sin square theta cos square theta common, we will get in the brackets sin square theta plus cos square theta. Sin square theta plus cos square theta value is 1. So we are getting the value as 9a square cos square theta sin square theta. So what are the limits? So limits, we have to find out the limits for theta. So before that, we'll go what is the, how it will look like, this curve. So this is asteroid. It is symmetric about both x axis and as well as the y axis. Suppose if you take the value as, see in the first quadrant 0 to a, see here this is a, and suppose if you take b, in the first quadrant arc length, so is same as in the second quadrant as well as in the third quadrant and in the fourth quadrant. So to find entire length of the asteroid, it's, if you consider only in the first quadrant, it is enough. So we can write 4 times the length of the arc in the first quadrant. So what are the limits for this? See here, x is equals to a cos cube theta. On this x axis, theta will be 0, and on the y axis here, theta is pi by 2. So what is the total length? What is the length of the whole length of the asteroid? That is equals to, because we are considering in the 4 quadrants, so total length will be 4 times integral. Theta is integral. Theta varies from 0 to pi by 2. So we have to consider 4 times integral 0 to pi by 2 under root of dx by d theta whole square plus dy by d theta whole square d theta. So already we simplified this, that value we got it as 9a square sin square theta cos square theta. If you remove the root, what we are getting, 9a sin theta cos theta d theta. Now sin theta cos theta can be written as sin 2 theta by 2. So root 9a square is nothing but 3a. So sin theta cos theta can be written as sin 2 theta by 2. Integrate sin 2 theta. Sin 2 theta integration is minus cos 2 theta by 2. Apply the limits 0 to pi by 2. So if you apply the limits, upper limit cos 2 theta is nothing but cos 2 into pi by 2, that is cos pi. Cos pi value is minus 1, so minus of minus, it will become plus 1. Similarly, apply the lower limit 0. When we are applying the lower limit, we will take minus sign. So already one minus sign is there. So as sin 2 theta integration is minus cos theta, if you apply the lower limit, minus of minus will become plus. Plus, what is the cos 0 value? Cos 0 is 1. So 1 plus 1, we are getting the value as, total value as 3a into, so we are getting the value as 6a. So this is the whole length of the asteroid. Now next, so already we did Cartesian form and as well as in the parametric form. Now suppose if the given curve is in the form of polar. So polar form, how to find the whole length or how to find the length of the arc. So I already told you if it is in the polar form, what is the formula? So if the curve is in the form of r is equals to f of theta, we will take the integral theta 1 to theta 2 under root of r square plus dr by d theta whole square into d theta. So that means we have to write the given curve in the form of r is equals to f of theta and we have to find the limits for theta and integrate in between theta 1 and theta 2. So what here the given equation is a cardioid. R is equals to a into 1 minus cos theta whole square. So r is equals to a into 1 minus cos theta whole square. So for this is a cardioid, we have to find the perimeter of the cardioid, that is nothing but the whole length of the cardioid. So first we will find out what is r square plus dr by d theta whole square. What is dr by d theta? A differentiation, a into 1 minus cos theta, 1 differentiation is 0, minus cos theta differentiation is nothing but sin theta. So what is dr by d theta? A sin theta. Now substitute in the equation r square plus dr by d theta whole square. Substituting r as a into 1 minus cos theta and dr by d theta as a into sin theta. Now simplify it, a square into 1 minus cos theta whole square plus a square sin square theta. If you simplify, so what we are getting, this is as a square into 1 plus cos square theta minus 2 cos theta plus sin square theta. What is sin square theta plus cos square theta? This value is nothing but 1. So what we are getting? 1 plus 1 2 minus 2 cos theta. If you take out 2 from the brackets, what will get? 2a square into 1 minus cos theta. So 1 minus cos theta, because we have to find the root value, 1 minus cos theta is nothing but 2 sin square theta by 2. So on the whole what we are getting? 4a square sin square theta by 2. So what is the root of under root of r square plus dr by d theta whole square? 4a square by 2 sin square theta by 2 root, that is nothing but 2a sin theta by 2. Now we need to find the limits for theta. So what are the limits? How it look like? What is the cardioid? So first I will show you cardioid. This is the cardioid. So this is again, it is symmetric about the initial line theta is equals to 0. When theta is 0, 1 minus cos theta means 1 minus 1, that will be 0. So here you will get 0. When theta is equals to pi, you will get the maximum value, that is as cos theta value is minus 1 minus cos theta is plus 1. So we will get 1 plus 1. So total value as 2a, this is the maximum value. It is symmetric about the initial line. The total length is nothing but 2. It is same as the above the initial line is same as the below the initial line. So we will take the total length as 2 times integral 0 to, what are the theta varying from? Here at initial point the theta value is 0 and at the last point, at the final point, terminal point, theta is pi. So we will take the theta value as 0 to pi. So now what will be the length of the arc? Length of the arc is equals to 2 times integral 0 to pi under root of r square plus dr by d theta whole square d theta. So already we got the value as r square plus dr by d theta whole square d theta value as under root of 4a square sin square theta by 2 d theta. So if you remove the root, we are getting 2a sin theta by 2. Same sin theta by 2 integration is minus cos theta by 2 by 1 by 2. So if you simplify that value, what we are getting? 8a into minus cos theta by 2. Apply the limits 0 to pi. Upper limit is cos pi by 2, cos 90 degrees 0. So the lower limit, when we are applying the lower limit, we will take minus of minus. So that will become plus. Cos 0 value is 1. So what is the length of the cardioid? What is the total length of the cardioid or perimeter of the cardioid is 8a. If the cardioid is equation is r is equals to a into 1 minus cos theta, we are getting the total length or perimeter of the cardioid as 8a. Now so we got the value if the given equation is in terms of r is equals to f of theta, so we got the value as integral 0 to theta 1 to theta 2 under root of r square plus dr by d theta whole square d theta. Suppose if the equation is in other way, suppose see here the given equation is in terms of r theta is equals to a, and it varies from r is equals to a to r is equals to 2a. So that means we need to integrate with respect to a and with respect to r. So you are given that prove that the length of the arc of the hyperbolic spiral r theta is equals to a taken from the point r is equals to a to r is equals to 2a. So for this we have to integrate with respect to r. So we will take the formula as under root of 1 plus r square d theta by dr whole square into dr, given that r is varying from 0 to a to 2a. Similar manner, r theta is a is equals to theta by r, we will find out d theta by dr, and also we will substitute the value in the equation. So we will get the value after substitution and after simplification. What we are getting? Under root of a square plus r square by r dr. Now we need to integrate this. So to integrate this directly we cannot integrate, so we will go for the substitution method. So take a square plus r square as t square, differentiation, if you differentiate we will get 2r dr as 2t dt. So what are the limits? When r is a, t square is 2a square, so t will be root 2a, and when r is 2a, a square plus 4a square, that is 5a square, r square is 5a square, r is root 5a. Now what the integral will become? Root 2a to root 5a, r square by r square minus a square, t square by t square minus a square dt on integration. So if you integrate with respect to t, we will get the value as root 5 minus root 2 plus log of 2 plus root 8 by 1 plus root 5. So this is the length of the arcs. How to find using the integration? So initially what we did to find the length of the arc, so we are approximating by taking a straight line. So to get, if you take direct straight line, will not get the accurate value. So because of that, what we are taking, we are increasing the number of points on the curve. By increasing number of points, that means we are taking n a larger value and a larger. That means as n tends to infinity, we will get that straight line tends to a point. So we will get accurate value. So for that, what we are taking? So that equation is nothing but under root of, how we are taking the length of the straight line as under root of dx square plus delta x square plus delta y square, and applying the limit. So as n tends to infinity, it is converted into the integration. So that is integral a to b under root of 1 plus dy by dx whole square into dx. So that is if the given equation is in the form of y is equals to f of x. Suppose y limits are given, the given equation is in the form of x is equals to f of y or g of y. How to find the length of the arc? So for that, what we are taking? So we are taking d plus under root of 1 plus dx by dy whole square into dy. Similarly, we are taking parametric form. If the function is given in terms of theta or in terms of t, we are changing the formula as dx by dt whole square plus dy by dt whole square into dt. And also if the curve is given in the form of polar, that is r is equals to f of theta or theta is equals to j of r, then according to the formula, so what is the formula? If integral theta 1 to theta 2 under root of r square plus dr by d theta whole square into d theta r under root of 1 plus r square d theta by dr whole square into dr. So in this way today, so we can find the lengths of the arcs by using the integration in the given limits for the Cartesian equations and parametric Cartesian equations and also polar forms.